Okay, good morning. We were assigned question 1 for homework set 1, and it's going to be finding the integral from 0 to pi fourths of x cosine of x dx. And for this problem, we felt that integration by parts is going to be our best method. And what we did here was we included the formula for using this integration by parts, which is going to be the integral of u dv is equal to u times v minus the integral of v du. And we chose x as our u and cosine of x dx as our dv. And of course, the derivative of x is 1 dx, and the integral of cosine of x dx is sine of x. So after plugging in our u and v, we end up with x sine of x minus the integral of sine of x times 1 dx, which is actually the same as x sine x minus the integral of sine x dx. And some further simplifying, we have x sine of x minus negative cosine of x, which is the integral of sine x, which is equal to x sine of x plus cosine of x, and we're going to evaluate that from 0 to pi quarters. And the function from function of pi fourths is equal to pi fourths sine of pi fourths plus cosine of pi fourths. And I want to note that sine of pi fourths is 1 over square root 2, and that is equal to cosine of pi fourths, which is also 1 over square root 2. And the function evaluated at 0 is equal to 0 sine of 0, and we can just eliminate that because anything times 0 is 0, plus cosine of 0, which is equal to 1. We end up with pi fourths times 1 over square root 2 plus 1 over square root 2 minus 1. This can be further simplified to pi over 4 square root 2 plus 1 over square root 2 minus 1. Punching that into the calculator, we end up with 0.262467. Thank you.